Safely navigating at night requires a clear, focused beam of light. When road hazards become difficult to see, degraded headlight lenses are the likely culprit. Restoration brings back the clarity required for safe driving while avoiding the high cost of a full unit replacement. Modern headlights use lightweight polycarbonate plastic instead of glass, protected by a thin factory UV coating. Over time, sunlight exposure causes this layer to oxidize, becoming jagged and yellow. This forces the light to scatter erratically instead of focusing forward. This yellowing is a permanent change to the surface material caused by environmental exposure. Because the oxidation is embedded in the plastic itself, standard soap and water cannot clear the haze. Ignoring this degradation cripples the headlight's ability to project a safe, concentrated beam of light, leaving you to drive in dangerously dim conditions. A controlled AAA study quantified exactly how much visibility is lost when these lenses degrade. Researchers used an accredited laboratory to measure the light output of headlights from two popular 11-year-old sedans. The study revealed that badly yellowed lenses produce only 20% of the light output compared to new headlights. This 80% reduction in performance creates a significant safety risk during nighttime driving. These performance drops also trigger serious legal consequences under UK MOT inspection standards, which require headlamps to maintain the correct light color, adequate output, and a precise beam image cutoff. A lens that only puts out 20% of its intended light, or a beam pattern distorted by surface oxidation, results in an automatic MOT failure. Restoring the lens is a mandatory safety requirement to maintain roadworthiness. This project ensures your vehicle remains both safe and legally compliant on the road. Start by physically inspecting the headlight unit. Verify that the yellowing and surface haze are located on the exterior plastic by running your hand across the lens to feel for rough oxidation. Check for internal condensation or deep structural cracks in the plastic. These issues indicate a failed seal or internal damage that requires a complete unit replacement rather than a surface restoration. If the damage is strictly external, prepare your workspace. Choose a cool, dry area out of direct sunlight, and wear nitrile gloves to protect your skin from the sanding residue and chemicals. Wash the lens thoroughly with soap and water to remove loose dirt. Then apply heavy automotive masking tape around the perimeter of the light to protect the car's surrounding paint from the sanding process. Skipping this preparation risks permanent damage to your car's finish. Careful masking ensures the abrasive work is confined strictly to the headlight lens. The wet sanding phase begins the actual restoration. It is vital to use the specific starting grit recommended by your kit's instructions to ensure you are aggressively removing the failed coating. Use plenty of water and sand with even, overlapping passes. Your goal is to strip away the oxidized layer uniformly across the entire lens. Avoid staying in one spot for too long to prevent uneven wear in the plastic. As you sand, a milky white residue will flow off the lens. This runoff is the oxidized plastic being successfully leveled and removed from the surface. Progress through incrementally finer grits of sandpaper, such as moving from 400 to 1000 and finally 2000 grit. Keep the lens and the paper wet throughout the process to lubricate the surface and prevent the plastic from overheating. The sanding phase is complete when the dry lens has a uniform, dull, frosted white appearance. Any remaining yellow spots or clear patches indicate that the old UV coating hasn't been fully removed yet. This process is mandatory because the failed, microscopically jagged UV coating must be completely stripped away to reveal the fresh plastic underneath. Next, use a polishing compound to mechanically refine the surface. This compound smooths out the micro scratches left by the final sanding grit, bringing back optical clarity to the plastic. Apply the polish to a pad and buff the lens until the frosted finish disappears. This action restores the headlight to a state of crystal clear optical transparency. Stopping at this stage is a common mistake. Without protection, the bare polycarbonate is highly vulnerable to UV rays and will oxidize again within weeks. The final, vital step is applying a specialized UV clear coat or activator wipe. This chemical layer seals the polished plastic and provides a new barrier against the elements. Follow the manufacturer's exact application and curing times. Allowing the UV protectant to bonding correctly ensures the restoration lasts for the long term. While polishing recovers immediate visibility, This chemical UV protection is what keeps the headlights safe and legal for years to come. Once the coating has cured, remove the masking tape. Turn on the headlights and project the beams against a flat surface, like a garage door, to verify the results. The restored beam should be crisp and white, with a sharp cutoff. The scattered yellow haze seen at the beginning of the process should be completely gone. This restoration recovers the lens to meet MOT standards, though no surface treatment is invincible against permanent environmental wear. Establish a routine of regular visual inspections. Catching early signs of hazing allows you to reapply protection before nighttime visibility is compromised. Mastering this controlled process transforms a dangerous MOT-failing hazard into a reliable, safe component. Applying the correct technique makes expensive unit replacements unnecessary.